So all of these first three problems are basically just what this was operation last week. And then I'm going to get into something that's sort of the same idea, but a little bit different. So to begin with, let's do a super easy, mega easy warm up like this. And the directions are, of course, this one word, factor, right? And so if you've been missing some school or not, it's been a weekend perhaps. Remember the act of factoring something is the act of breaking it down into pieces that multiply to make it. And so when we factor a quadratic trinomial like this, what's step one? Build your shells, right? And those shells, remember, are called the factors. This thing is called a factor, and this thing is called a factor, right? So having the shells is pretty important. What's going to go in the shells? X's. And this is the part where if you were to start getting stuck, this is where we expect it to happen right here. And it is the number one. Well, I don't have any words strong enough to express to you how important this is, the signs. I tried, but it just, I can't quite find the right words. It's all about the signs. I have to either put in a plus and a plus or a minus and a minus or one of each. Which one will I do here? Has to be one of each. And the reason is because whatever I put in these two spaces have to multiply to make negative something. The only way to multiply to make a negative answer is if you have one positive and one negative. Okay. And now you think back about your times tables and you say, okay, I only have one primary mission. And my mission is to multiply to make the number 40. So my options are 1 and 40, 40 and 1, 2 and 20, 20 and 1, 4 and 10, 10 and 4, 5 and 8, 8 and 5. And so in this case, what would you like to try? Say again? 5 and 8? Sure. So I could just kind of randomly stick in a 5 and an 8. And the thing about this is that you get, I can't say this all the time, you get to grade your own tests. This is the only chapter, like almost ever, where you literally can grade your own paper before you should know if you have 100% before you even put it on my desk. And we do that by testing. You don't test this red and you don't test this yellow because you know what they equal. Remember that. You controlled them. What you do test is purple and green. You grade it yourself. People still call me over and say, can you check if this is right? And of course, I'm always going to say yes. But the point is like, well, you really could have checked it yourself, right? Just like this. What does purple make? Mm-hmm. And the green makes plus 5. And what is negative 8x plus 5x? Which is exactly what we wanted, which means that this is the answer. Just sort of as a gauge for you, if you struggled with that one, consider yourself a little bit behind at this point. Okay. That should be what you would consider to be pretty light work by this point, having spent a couple days on factoring now. So let's up the difficulty a little bit. Do you remember what I, as your teacher, do to up the difficulty when I want to just make it a little harder? Mm-hmm.
When you have to do the two show,
Mhm.
that's only when it's like 4 or 6.
Correct. Yeah. So what changes when we up the difficulty level? Nope, not necessarily. It's this. I mean, there was yeah, and you guys are pretty amazing learners. Like maybe I'm thinking that something would be harder when in reality it's not. I consider this a bump up in difficulty because the 5 is going to change the dynamic of some things. But if it doesn't bother you guys, then good on you. Like I'm impressed. But I usually see this is where the first sort of bump occurs for people. So when I put a 5 or a 3 or something, a number in front of x squared, things tend to get a little bit rougher. So let's build our shells. And this problem only requires one pair of shells because do you guys remember what 5 is called? There's a name for that. It's called a prime number. And when a number is prime, that means that it can only be divided one way, itself times 1. So then we know in this case that we do not need multiple sets of shells. But you already know exactly where I'm going to be going with the third example, right? So let's finish this one first. What are the signs going to be? 100% negative, negative. Give me a long distance right here. High five. Did you have a question, or you just want to say that?
If it's 2x squared, would it be x and x, or
If
what?
it was 2x squared, it would be 2x and 1x.
Would you have to make it second shot? No.
No, because 2 is a prime. Because 2 can only be 2 times 1,
So
right?
4, 6, 8, those ones?
Any other even number, or like 15 or 9, anything that can be divided down more than one way is going to require more sets of shells, right? Like 9 times 1, 3 times 3, right?
Or 14?
14 could be 14 times 1 or 7 times 2. Yes. Okay. Great job on the signs, by the way. That's to me everything. Fight man, that's my Mount Everest for factoring. Can I get everyone to understand the signs? And you crushed it. They are two minuses because they multiply to make a positive, but add to make a negative. And you don't have a lot of options here. You have 1 and 6 or 6 and 1. It does matter where you put them, or 2 and 3 and 3 and 2. What works? Let's find it yet. In that order, Willow says we should put the 6 here and the 1 here. And we certainly don't want to put those switched because then the 6 would buff with the 5, right? So let's test out Willow's handiwork here. What does purple make? And what does green make? And when you add those together, you get, which is exactly what we wanted. So Willow hit the nail on the head there. Okay. And so now to up to the final difficulty level is where I take a number in front, but I make it not prime. Right? So this is all sort of stuff we've talked about last week. So for this one, we're going to do 6x squared plus 13x minus 28. And instantly the red flag of danger sort of goes up for us because we recognize that 6 can be broken down as, yes, I get it, 6x and 1x like this, but it can also be broken down as 3x and 2x like this. So does everyone understand why we need two sets of shells? And why this, by definition, in theory, is twice as hard as its predecessor, right? Okay, good. Then the signs. What are the signs? It cannot be negatives on both. Because if I put a negative here and a negative here, and I multiply a negative number by a negative number, I will get a positive number, and that is impossible. So again, if the number in the back is a negative, that's all I need to know. There will officially be one of each like this. And you can alternate them, put them in whatever order you want. You're probably going to wind up having to change them anyways. So, well, half the time. Do you have a question?
Yeah.
Good job. That's the hard part. And now the easy part is just roll up your sleeves and try, and you all know the most common number pair that multiplies to make 28 is 4 times 7. So we have a 4 and a 7 and a 7 and 4. I'd always start there. And if I don't find it, then I'll branch outwards. I'll work the factors apart and then I'll go to like 2, 14, 14. But I think it's usually going to be found. Oops, that was supposed to say 4, not 7 times 7. Apologies. So has anyone found it already while I was yip yapping? I'll just have some coffee while I wait for your input. 1:23 p.m. coffee is wonderful.
Four and 7.
In that order. Thank you, Gavin, for breaking the silence. I appreciate that. So, and I know some of you guys were honestly just mathing it in your head like Gavin was, and that's fine too. Some kids factor different ways. Some kids, I try to tell them, just get in there and write numbers down, and if they don't work, erase them. But I do know some of you guys like to stare at it, and you're actually doing the purple and green in your heads, which more power to you there. So let's check Gavin's handiwork and see. And again, I'm not going to test Gavin on does that make 6x squared? And I'm not going to test Gavin on does that make negative 28? I'm not interested in that because I know that those work. What I'm interested in is the purple and the green. So what does purple make in this case? Positive 21x's, and then what does green make in the middle? Minus 8x. Okay, negative 4 times positive 2, negative 8x. And when you add the purple and the green together, what do you get? You get what you wanted. So I think Gavin was kind of hard at work back there. That didn't much sound like the voice of someone who was guessing. I think he'd already worked it out and good job. So works. And if you can't see that, then don't be the kind of person that stares at it. Okay. Not everyone should or could do that. What everyone should be doing is just saying YOLO and you just pick a couple numbers that make 28 and throw them in. And if they don't work, that's okay. Flip your pencil over, erase, and try something else. It's part of the deal. But that's what you should now know how to do based on last week in this class. Does it mean you're an expert at it? No, but that's where we should be. Which leads us then to today's notes, which today is 413. And today you're going to learn how to factor something called a difference of two squares. So there are 5 examples, 6 examples in today's notes, but once we get to cooking on these don't take long at all. So this is called a difference of two squares. And the reason we call it that is because, I'm sorry, it is quite literally a difference. See that? A difference is a minus sign of two squares. The reason we call x squared a square is because it can be square rooted. And the reason we call 4 a square is because it can be square rooted. So perhaps I'm getting ahead of myself. Does anyone know how to factor this? I would be surprised if you did, quite frankly. But pay attention now and kind of watch the television. How would you feel if instead of the problem that I put on the board, if I gave you this? That you would agree makes it look more like what we just talked about, right? Isn't this just a normal factoring problem now? So can't I just build my shells? What are my signs? Got to be one of each because they multiply to make a negative 4. So I'm going to put a plus in one and a minus in the other. And what numbers do we want? I mean, you have options, but there's really only one sensible one to get this 0 in the middle. What is it? A 2 and a 2. And what's nice about a difference of two squares is that you don't even have to really guess and check like we do with the normal factoring. Normal factoring, you got to try it, test it, erase it, try it, test it, erase it. This one, you just know. You can see the writing on the wall. The outsides are going to equal the dead opposite of the insides, right? You will not see the problem written as x squared plus 0x minus 4. You will see it written as x squared minus 4, and it's your job to recognize, oh, it's one of those shortcut guys. Okay? Will these always have one plus and one minus? Yes, they will. They have to by definition, because if it's a difference of two squares and this thing that I'm circling in red is a minus sign, then by definition, you'll always need one positive and one negative. Besides, how could they possibly cancel if you didn't have one of each? Did I just add an X to what?
0.
Yeah, I just put that in there just to make a point, but it's gone now. You can't see it anymore. It's gone. Nothing there. Good. Let's go again. Ready, go.
Doesn't matter. I need to be like that.
You see it? Go ahead. What is it? I'm going to show you a trick. Is that a square? If you don't know what I mean, now would be a good time to say, could you please tell me what that means? A square is something that is square rootable or something that was obtained by squaring something else. Is x squared a square? Yes, it is. What's its square root? This would be a great time if you've kind of fallen asleep and you're like, oh, I can't listen. Wake back up and listen now because I need you for like 2 minutes solid good. What is the square root of the red thing? It is x. I'm going to write that down and you should too. What is the square root of the yellow thing? Write that down because now all you need are to put those in place. Watch this. Red goes here, yellow goes here, plus in one, minus in the other, done.
Okay, mine's at a minus, which I get the minus there.
Yes.
But then I did those.
These will not end in pluses until you get to algebra 2. In algebra 2, we will do things like this. This is called a sum of cubes, which is factorable. A sum of squares like this is not factorable using real numbers because by definition, you can't get the 0x that you need in the middle if you have both pluses or both minuses, right? It was just there to make a point. Yeah, I almost regret having written it at all because that's twice today that someone's asked me about it. So good. Let's go again. Okay, that's how you factor a difference of squares. These should become your favorite. I've said that about many things, and then they turns out not to be true. But like this should be a 4 second. This should take you 1 second to figure out and 4 seconds to write down. Correct, Cage. Good job. It's very quick. Square root plus square root times square root minus square root. Done. Quick. Now I'm going to change it up a little bit, but we're still going to embrace the same thinking. So for these last three examples, I'm going to throw a little bit of extra flavor in there. Is the red thing, is that a square? What's its square root? 2x. Is this yellow thing a square? What's its square root? And then all you need now are those building blocks. Square root, plus, minus, done.
What happened? Like three.
Then it's not a difference of squares. Okay. The
It'll
only
just be X. And then
if you see a problem of this format, if you see a problem of this format, it's not going to be a binomial like this. Okay. I'm talking about very special case. So like I'm not going to give you like 3x squared minus 24. Like that's not a difference of squares. Okay. So I'm not going to
give this one.
I'm not going to give you one. Nope. If you see one that looks like this, it's going to be a square rootable minus in the middle. Okay. For now. Let's go again. 9x squared minus 121. Register first off, is it a difference of squares? Yes, it is. That is a difference sign in the middle. And 9x squared is a square. 121 is a square. What's the square root of the red thing? 3x. What's the square root of the yellow thing? And now you just build your factors out of those. Okay? And I assume you've got it. Let's do one more just to really just like wedge the piece into place. And these stick out like a sore thumb. I mean, they don't look like normal factoring problems, right? Correct. Square root plus square root minus square root. Done, fast, easy.
We have a whole worksheet on.
No, it's funny. Like I always feel like in algebra, when I teach students like x equals 4 is a vertical line. So, you go right 4 and then you graph a line like this. In my crazy little mind, I always think that should be the easiest thing, and it turns out to be the hardest, right? So I sometimes worry about difference of squares. I feel like those should be quick, easy factoring problems, but that thinking sometimes is not really true. So that's the new part for today. So the old part was those 3 warm-up problems. The new part is the difference of 2 squares. And the new worksheet that I'm about to hand out to you will contain some differences of squares. So let me try to sort of put this in a package for you. Last week, we did assignment number 46, which was on Delta Math. And it was problems like this, where we just multiplied, like 3x minus 4 times x plus 2. That should be done. Got it? And then I gave you assignment number 47, which was a worksheet, like on paper. And it was just like this. Same thing, just practice with multiplication. That should be done. Clear? Then later in the week, we learned something called factoring, and then came assignment number 48, which was in Delta Math. And that was where we got our first real look at factoring things like x squared minus 4x minus 32. Okay, that should probably not be done. I know that for a few of you, you probably did get to 100%. Good job on that one, but I understand that this one is still a work in progress. And then today I'm giving you assignment 49, which is a worksheet, and it will contain this, but it will also contain these, the new things today. So that's me trying to put it in sort of a nutshell for you. It's like that's where we sit in this class right now. 46 and 47 really should be done. 48 and 49, I fully understand you're still working on these. So the rest of the hour is yours. You've got a ton of time to work. I'm going to hand out assignment 49. I trust you're going to have lots of, can I go over this with you, or can you help me with this kind of questions? So I'll just keep the recording alive and paused. And when you have questions, I'll just throw them in. Got it?